Okay, so we're going to look at an observer now and really ask the question, what is an observer in general relativity? So if we take a spacetime manifold um, and we assume we have some world line, okay, of let's say some particle, classical particle, throughout spacetime. Well, that particle is going to, let's say it emits light, okay? So let's say that that particle emits light over the course of its world line, okay? Um, and an observer would be someone on a different world line that's going to receive the light from the first world line, right? And so how do we model this mathematically using a coordinate system? Because and the idea is you need to use the tangent space. So you view an observer will have a tangent space attached to them. And, you connect the tangent space to the spacetime manifold via the exponential map. So you take the logarithm of the world line, and then that of the world line of the particle that you're observing, that logarithm is some curve in the tangent space to the observer, okay? But the problem is that you can't just look at the logarithm alone because the observer doesn't see the world line of the particle, right? The observer sees a three-dimensional reality. And the observer sees the intersection, the transversal intersection of the family of light cones emanated from that particle at certain times. So the particle will emanate light at certain times, at certain distinct events in space-time, okay? And that light will reach the world line of the observer at certain times, okay? And so really the idea of an observer is essentially a fixed foliation of space-time into space-like hypersurfaces. Because that foliation into the space-like hypersurfaces, well, that doesn't necessarily need to be an observer, but you can think about that an example of, or like an observer is an example of foliation of space-time into space-like hyperplanes. And and then these space-like hyperplanes are parametrized according to the proper time of the observer, and the light cones from the particle that's being observed, those light cones, which are emanated, remember, the particle is not just the world line itself, like the particle actually traces out the world line. Okay, so the particle is like a time-evolving delta mass according to its own proper time, right? Particles, some delta mass moving in space-time, basically. The light cones emanating from that delta mass are going to intersect the space-like foliation of the observer. The space-like foliation into hyperplanes generated by the observer. This light will reach this foliation, obviously. It will reach every leaf of the foliation. But the point is that we care about when the time that the particle actually emits the light, that time, the particle emits the light, and then that light travels through the space-time manifold along the light cone, and eventually that light cone, right, over a finite period of time, will intersect the observer's space-like hyperplane that they're currently sitting in. Because, again, and this is because light moves faster than the observer. The observer is moving slower than the speed of light. And so then we can ask the question, okay, so if light's emanated from a delta mass in space-time, and it intersects this this space-like foliation at some critical time, does it intersect transversely? And when can that light actually be detected by the observer? Okay. And so we get these regions of detection where the observer, the moving observer, essentially has certain regions of space-time which they can observe at any given moment, or which they are observing at any given moment. They aren't observing their own space-time around them. They're really observing the electromagnetic waves which occur from some field of view in space-time, which is, and those light waves were emanated from points which are in the observer's past. Okay, from points in space-time which are in the observer's past. So the role of the observer then in this space-time setting is to foliate the space-time manifold in a specific way, and that foliation gives rise to a notion of dynamics, like time evolution, right? The way that we experience the world in a dynamical way as observers, and according to our own proper time. This parameterization of this foliation to space-like hypersurfaces. Okay. So